Welcome to Small Animals Matter, with me, Dr. Miles. Everything that we thought we knew about fish, and about oysters, mussels and other bivalves, turns out to have been completely wrong. Whether that's the idea that fish only have 3-second memories, or whether it's the idea that oysters and other bivalves don't have a central nervous system under the primary, meaningful definition of a central nervous system, which I'll get back to. All of these things are just incorrect. And these things matter because we're basing our decisions on myths and misunderstandings. So let's look at the actual factual evidence. And in relation to fish, this evidence has been summed up by the biologist Dr. Jonathan Balcombe in this book, What a Fish Knows. And he's brought together the research findings from different university research projects, different biology departments, and also ethology studies, the study of the behaviour of animals. And the material contained in the book is absolutely fascinating. And that's why it's a bestseller. It's an international bestseller. It's a New York Times bestseller. For example, flounders have got such sophisticated camouflage systems that if you put a chessboard on the floor of a fish tank, a flounder will go from having a normal sort of unremarkable grey-green colour to having black and white squares on their skin, which exactly match onto the black and white squares in the fish tank, on the floor of the fish tank. And if they're resting on gravel, for example, little brown and white stones, they get an image of little brown and white stones on their skin, almost like a photograph, so that you can't really see where the fish ends and the gravel begins. And if you want to see those photographs, then just pause this video and look for the link in the video description. But the most amazing things about fish are to do with cognition and behaviour. For example, they have perfectly good memories. Small goby fish, for example, have got photographic memories, much better memories than human beings have got. Goldfish can remember physical details over a period of at least 12 months, which is how far they observed this for, but if they'd observed for longer, maybe it's longer than 12 months. And other types of carp can remember things for at least 3 years. It has also been shown that fish can recognise different human faces. They can recognise different genres of music. Yes, they even did experiments to do with that. And they can use tools to carry out tasks, in other words, tool use, which we used to think only human beings could do, and then it turned out that other great apes could do this, and corvid birds could do this, and now it turns out that fish can do it as well. Every time we think that there's a barrier between ourselves and the rest of the animal kingdom, it turns out that it's just illusory, and the evidence just wrecks whatever myths we had in our heads about this. And probably the most damaging myth of all is to do with fish supposedly not being able to experience pain and suffering. And of course that's covered in detail in this book. And the studies on this have been extensive. They've largely been done by two biologists called Braithwaite and Snedden. And they've managed to put microelectrodes into the single nerve cell bodies in the nervous systems of fish, so that they can actually measure the electrical impulses going along the nervous system from the skin when things like heat and acid are applied. Now these are obviously extremely unethical experiments. They shouldn't be happening, just as people shouldn't be keeping fish in tanks, especially smaller tanks. But at least the evidence is there now, and we know that fish do experience pain. And it's not just the initial nerve response. They've also been able to measure the gill beats rate, which has been established from other studies as being a very good measure of distress levels in fish. And those distress reactions kick in when the painful stimuli are applied. They've also backed this up with a range of different behavioural observations and studies as well. For example, when fish are experiencing pain, their decision-making changes. They make worse decisions because they are distracted by the pain. And when the fish are then given painkillers, their behaviour returns to normal. And the painkillers are the same ones which work on human beings. Not only that, but the fish are actually willing to give up something which they normally preferred, such as being in a nicer tank, if the more barren tank contains painkillers dissolved into the water. And so they're willing to go through that trade-off, that they've got an option between the different tanks, there's a pipe between them, and they choose to go into the worst tank in normal circumstances if that tank can provide them with pain relief, because they want to get that relief from the pain. And these kinds of studies on fish have gone into lots of other areas as well. In my insects dream video, I discussed the fact that crickets and flies and other creatures, other insects, can experience depressive states as measured by their decision making, which can be either more optimistic or more pessimistic. And research has shown that they can be brought out of these depressive states if you use pharmaceutical interventions, antidepressants. And you give them the exact same antidepressants which work on human beings. It has the same effect on insects. And it turns out that the exact same depressive states and relief from the depressive state applies with fish as well. And in the Insects Dream video, I also discussed the fact that insects enjoy playing. And again, that applies to fish. And in fact, one of the most interesting parts of this book refers to, describes the fish going for bubble rides, which is when there's a machine at the top of the fish tank sending a stream of bubbles across the top of the water. And the fish like to swim up and jump into the stream of bubbles and go for a ride across the top, and then they swim around again and jump back into the stream, almost like going for rides on a helter-skelter over and over. And if you've ever made a fuss of a cat, which I'm sure you have, and if you're using your hand, as you know, the cat will nuzzle against your hand and then turn around and sort of pass through and give themselves another go and this kind of thing. And if you'd like to see footage of fish doing exactly the same thing, then again look for the link in the video description. There have also been some really interesting cognitive tests in relation to fish. Most notably, there was a whole series of experiments to do with giving them 2 plates of food. Now, the 2 plates of food were different colours, but they had the same amount of food on them. And after 2 minutes, one of the plates would be removed. So the fish had to figure out how to get more food in this scenario, which isn't that straightforward, because they could think that going to the temporary one was a waste of time because it would just be removed, so you may as well go to the permanent one. But of course, it's actually better if you go to the temporary one first, because at least you can get the food while it's available. So it's quite a tricky little cognitive test. And the fish were able to figure this out and solve it and get more food more quickly than chimpanzees, when the chimpanzees were given the same test. So the idea that fish are stupid is a complete myth, just like the idea that they have a 2-second memory is a complete myth. The idea that they don't experience pain or distress, that's a complete myth. There's also really interesting material in the book to do with fish exhibiting compassionate behaviour. There's an amazing account of a fish called Big Red, who was in a tank, and they introduced a deformed fish into the tank called Blackie. And Blackie couldn't swim properly, but Big Red decided to assist Blackie by lifting him up and helping him to swim around. And at feeding time, he would lift Blackie up and guide him over, carry him over to the food so that he could feed properly. And this is the kind of thing which, you know, we assume might sometimes happen in relation to dogs or dolphins, but no, it can happen in relation to fish as well. But then, this is where things get really weird. What if they didn't do these things? What if they didn't show compassionate behaviour? And what if a human or a non-human being had a severe cognitive impairment, so they wouldn't be able to solve the plates test? Or what if they had profound amnesia? What if the myth about very short memories was actually true? And what if they did have an inability to experience pain? I mean, some human beings can't experience pain. And, you know, we wouldn't say that it's okay to harm them. So none of these things actually make it okay to harm and exploit these creatures, even in the scenario where they didn't tick these boxes. They have cerebral neurons, which are the foundation of conscious experience. Plants, on the other hand, don't have any kind of neuron, let alone cerebral neurons. And given that human and non-human beings are living a conscious life with conscious experiences, how could it be right to take that away from them? we need to avoid causing harm and exploitation as much as possible. And things like IQ level, or even pain level, don't ultimately come into it. So we need to be extremely careful that when we are debunking false claims, we don't accidentally validate false criteria for determining moral value. It should come down to consciousness rather than these adjuncts of consciousness. And when it comes to oysters, mussels and other bivalves, once again, they have thousands of cerebral neurons, which once again are the foundation of conscious experience. And these are contained in their cerebral ganglion, which is a skull-less brain. It's their decision-making centre, and that's why researchers refer to it as a cerebral ganglion or as a cerebral ganglion bracket brain, or sometimes they just call it a brain. And whichever label you put on it, it's the same thing. It's their decision-making centre, it's their CPU, their central processing unit. And following on from that, there are two definitions of a central nervous system, the main one and a subsidiary one. The main definition is that the creature has got a nervous system, in other words, nerves running around the body, and that these nerves link back to and are controlled by a central processing unit, whether we label that as a brain or as something else. Well, oysters, mussels, clams and scallops all meet that primary definition of having a central nervous system. And then there's a secondary, subsidiary definition of a central nervous system, which is designed for vertebrate creatures. In other words, one with a skull and a spinal column. And so under that definition, the control unit needs to have a skull around it, and the nerves need to pass along a vertebral column. But those skeletal features don't have anything to do with neurology or sentience. How could they? And so the idea that because oysters and other bivalves don't meet that subsidiary definition is somehow meaningful, that's just not true. They do have a central nervous system under the definition, the main definition, which actually counts for anything. So bivalves have got cerebral neurons, which is saying consciousness. They've got a cerebral ganglion, aka brain. They've got a central nervous system under the primary definition. And it's also a myth that oysters and mussels don't move. They do move for defensive purposes, and it has been established ever since 1941, thanks to Pierron and Artemiev and other biologists, that these defensive actions are arising from conscious decisions in their cerebral ganglion, their skull-less brain, not from somatic reflexes. And so those are the main points to do with bivalves, and if you would like to know a little bit more about this stuff and see the full scientific sources, then you can just click on the link in the pinned comment below this video, where I go into this stuff in more detail. That's in the first two videos, in fact, on this channel, but I'll just link to one of them. And finally, a quick but important channel announcement. If I continued to make videos, they would then shunt the existing videos further down the list. And so when people came across my channel, they probably wouldn't even notice my main content, the most important things, and that includes the most important scientific evidence. And I don't want that stuff to get buried. So I'm now going to switch across to making community posts, which I now call just posts. Meanwhile, please leave a comment, because it really helps to get this video recommended to more people. It's extremely important to get this information out to as many people as we can. And please remember that small animals matter. Thanks for watching.